Hello everyone, in this video we are gonna try to explain this model that we have designed in order to be able to predict the energy produced by a power plant, taking into account certain features. So we in this notebook we first import all the packages that we will use in Python. Then we read the CSV that we were provided in the project with all the data, and then we see that the data is available here, all the rows, 9,500 rows, and we have 4 features: temperature, vacuum, exhaust, pressure, and humidity. And this is the target, the power production that we want to predict, the target. So I think that the model selected should be a linear regression, since we need to predict a numerical value. So we will focus on that model. But first we need to check which features are more important, and for that we will do a feature selection exercise. For that we can calculate a correlation matrix to see how much each of the features influence the target. We can see in this heat map that temperature and vacuum exhaust are like the highest, because they are very close to -1, so they have a very strong inverse relation, whereas these ones are a bit less strong. So in theory, these two should drive the target. But to visualize it better, we have done these scatter plots in which we see this is the temperature and this is the target, the energy produced. And we see that there is a very clear linear relationship. So this feature is going to be very important. We do the same for the exhaust, for the vacuum exhaust. And we see that even if there is more scatter, the relationship is quite clear also. However, when we go to the next feature, the pressure, then we just see a cloud. There is like kind of a trend here, but the points are very scattered. So at the end of this analysis, we conclude that we will focus on the first 2 features, and we will remove the other 2 that have less correlation with our target. Then we are going to start to try a model. In this case, we will try a multilinear regression model. Multilinear because we will take into account 2 features, the 2 features that are more important, temperature and vacuum exhaust. We separate our data in train and test, and then we separate the train in validation also, because to compare models we can only compare the models with the prediction on the validation set. So we fit here our linear regression model, we train it, and then we make it a prediction on the validation set, and we here calculate the R-square, which measures how the accuracy of the model, and also the mean square error. And in this case we have also computed the mean absolute error in order to see if there is a big difference between these 2. We know this one is less sensible to outliers, but for this one we will focus mainly on the root mean square error and the R-square. We see that the performance is really good. The highest that it can be is 1, so 91 is really high, 0.91. So this model seems to be very accurate, and if we see the error in percentage, in absolute percentage, is 0.87%, which is extremely low. We do the same for the same model, but only with 1 feature, the most important one. And as we were expecting, the performance is very similar. R-square is 0.89, and here was 0.91. So almost the same, and the error is almost the same. So this is very good. It feels like only the first feature already explains a lot. And here, just as an example, we did the same with 4 features, with all the features, and we see that the performance is 0.92, very, very similar. Adding many more data points is very, very similar. So the conclusion is that if we think about this triangle of accuracy, computational efficiency, and interpretability, we almost obtain the same accuracy with all the parameters, all the features, than with only the temperature. So we maximize the computational efficiency and the interpretability by just taking the temperature and as the only feature. So the model will be much simpler. And here we have the final prediction of the model with just the temperature, and we see that the performance is really good.